Saudi Arabia is building the tallest skyscraper in the world, but this time we're not talking about 500 meters, not even 1 kilometer. We're talking about an astonishing 2 kilometers in height. The proposed rise tower would make the Burj Khalifa look small by comparison, but is it actually possible to build a skyscraper of this scale? Or would a project like this ultimately fail because of the laws of physics? That's exactly what we're going to find out today. Just a few years ago, hardly anyone would have believed that a 2-kilometer tall building could even be seriously discussed. Yet that is exactly what has been making headlines. One important point, however, the rise tower is still in the planning and concept stage. Many details have not yet been officially confirmed. Even so, the idea alone demonstrates just how ambitious Saudi Arabia has become, because this project is far more than just another skyscraper. Saudi Arabia is currently undergoing a historic transformation. For decades, the country was known primarily for its vast oil reserves. But through its Vision 2030 initiative, the government is pursuing a completely new goal. It wants to diversify the economy beyond oil by investing in tourism, technology, international business, and foreign investment. And to achieve that, Saudi Arabia needs something money alone cannot buy: global attention. Dubai accomplished exactly that with the Burj Khalifa. The world's tallest building has become an international icon, with millions of people instantly associating Dubai's skyline with that single tower. Saudi Arabia now wants to create its own architectural landmark, but on an entirely different scale. And that's where the real challenge begins. Most people underestimate just how enormous 2 kilometers really are. The Burj Khalifa stands 828 meters tall. The proposed rise tower would be more than twice as high. You could almost stack 2 Burj Khalifas on top of each other and still not quite reach the planned height. Or imagine stacking 6 Eiffel Towers one above another. Only then do you begin to grasp the scale we're talking about, and that's exactly why existing engineering records cannot simply be scaled up. Beyond a certain height, the rules change completely. The first major challenge is the wind. At ground level, we often feel nothing more than a gentle breeze, but several hundred meters higher, conditions are entirely different. Powerful air currents constantly push against the building's exterior. The taller the structure becomes, the greater the surface exposed to these forces. Think of it like a tree. A small tree barely moves in the wind. A giant tree sways noticeably during every strong storm. For a skyscraper standing 2 kilometers tall, the forces involved would exceed anything today's high-rise buildings are designed to withstand. Surprisingly, however, the solution isn't to make the building as rigid as possible. It's actually the opposite. Modern skyscrapers are already designed to move slightly with the wind. These controlled movements prevent dangerous structural stresses from developing. Engineers don't try to eliminate movement. They try to control it. For a 2-kilometer tower, however, these systems would need to be taken to an entirely new level. But even if engineers could master the wind, another enormous challenge lies beneath the ground: the foundation. The taller a building becomes, the greater its weight. That massive load must be transferred safely into the earth below. Even the Burj Khalifa relies on an enormous foundation supported by deep reinforced concrete piles. A tower reaching 2 kilometers into the sky would place far greater pressure on the ground. Simply pouring more concrete wouldn't solve the problem. The soil itself must be capable of supporting the structure. Even tiny movements in the foundation could become dramatically amplified over a height of 2 kilometers. That's why geologists would likely spend years studying the site before construction could even begin. But the foundation is only half the challenge. The building materials themselves eventually reach their limits. Every additional floor increases the load carried by the floors beneath it. Eventually, the lowest levels would have to support forces that even today's strongest steel and high-performance concrete can barely withstand. That's why new material combinations and ultra-high-strength construction materials could play a crucial role. At this point, the boundaries between architecture, structural engineering, and materials science begin to blur. But let's assume all of these challenges have been solved. The tower is complete. Then another question arises: how do people actually get to the top? Even today, the elevators inside the Burj Khalifa are among the fastest in the world. Yet reaching the highest floors still takes nearly a minute. In a building more than twice as tall, conventional elevators quickly reach their limits. And it's not just about speed. The elevator cables themselves become a problem. The longer the cables are, the heavier they become. At a certain point, the cables become so heavy that they are essentially supporting their own weight. That's why companies are already developing rope-free elevator systems that use electromagnetic technology similar to magnetic levitation trains. In the future, these elevators could move not only vertically but also horizontally. For a building like the Rise Tower, technologies like these could become absolutely essential. But now the challenge becomes even greater. Before people can ride elevators to the top, millions of tons of construction materials first have to be transported there. Constructing an ordinary skyscraper is already an extraordinary logistical achievement. At 2 kilometers in height, the scale becomes something entirely different. Construction cranes would have to grow continuously as the tower rises. Thousands of workers would spend years building on a construction site that is constantly increasing in height. On top of that come extreme temperatures, sandstorms, and the enormous task of supplying materials to the entire site. Any significant delay could lead to enormous additional costs. And that brings us to another crucial question: money. No one can accurately estimate what a project like the Rise Tower would actually cost. No official construction budget has been released. However, experts generally agree that a project of this magnitude would cost significantly more than today's record-breaking skyscrapers. We're most likely talking about many billions of dollars. The real question, therefore, isn't whether Saudi Arabia can afford to build the tower. It's whether the tower would make economic sense over the long term. A skyscraper of this size has to be operated, maintained, and fully utilized for decades. Empty office space or unoccupied apartments could quickly turn such a project into a financial burden. That's why the Rise Tower is probably never intended to be just a standalone skyscraper. Instead, it could serve as the centerpiece of an entirely new urban district featuring hotels, offices, residential buildings, shopping centers, and entertainment facilities. The tower would become less of a single building and more the heart of an entire city. But that creates even more challenges. A building housing thousands of residents, workers, and visitors would require enormous amounts of electricity and water. Air conditioning systems would need to operate reliably even when outside temperatures exceed 40 degrees Celsius. Elevators, lighting, security systems, and ventilation would consume energy around the clock. That's why highly efficient energy systems and advanced building technologies would have to be incorporated from the very beginning. Safety is equally important. How do you evacuate a building that stands 2 kilometers tall? A simple fire alarm is no longer enough. Even today's super tall skyscrapers already include dedicated refugee floors, multiple emergency stairwells, and advanced fire protection systems. For a tower of this scale, these safety concepts would need to be reimagined from the ground up. And that's exactly why the Rise Tower isn't simply another architectural project. It would be a test of just how far modern engineering can truly go. But despite all the excitement, one thing should not be forgotten. The Rise Tower is not yet an active construction project. It remains primarily a vision. Whether it will actually be built, when construction might begin, or what the final design will ultimately look like all remain uncertain. Major megaprojects often evolve over many years. Some are redesigned, others are scaled back, and some are ultimately canceled altogether. Even so, the very discussion surrounding a 2-kilometer skyscraper demonstrates just how dramatically the limits of what seems possible have expanded over the past few decades. 100 years ago, a 300-meter building seemed almost unimaginable. Today, the Burj Khalifa rises to 828 meters, and now engineers are already discussing 2 kilometers. Whether the Rise Tower will one day dominate the skyline of Riyadh is something no one can say with certainty. But one thing is clear: if this megaproject ever becomes reality, it won't simply be the tallest building on Earth. It will be one of the most ambitious construction projects in human history, and a symbol of how far humanity is willing to go to turn the seemingly impossible into reality.